Hello guys, thanks for joining me today. I am Anmol Singh Yadav and today we will be talking about API hacking demystified, a technical overview for security professionals. Let me give you a brief idea about the topics we will be discussing. We will be discussing the introduction about API security. Then we will discuss the top 10 vulnerabilities of OWASP listed by OWASP in 2023. Then I will introduce you to some tools and techniques required for API penetration testing. We will conclude by discussing some case studies related to API hacking. So, hello, my name is Anmol Singh Yadav and I'm a cybersecurity researcher and enthusiast. I'm working as a site reliability engineer at Institutional Shareholder Services. I have recently graduated in computer science engineering with a specialization in cybersecurity and digital forensics. So, let's start by understanding the importance of API security. API, which is short form for Application Programming Interface, allows different applications and web services to communicate with each other. We are discussing API security since, according to the report of AKMI, the 83% of web application traffic these days is from API. So you can see that APIs are everywhere. We also study API security to ensure data privacy and confidentiality so that we can avoid any financial loss or reputational damage. Also, this API security is important for developers so that they can comply with the regulation and industry standards such as ISO. So, since we are talking about API security, let me tell you about what all data can be at risk if the security of API is not implemented properly. The financial information such as credit card detail, your bank account number, your personal information such as your name, contact detail, address and all. In fact, your health information including medical records, your health insurance, then comes your user authentication data such as your email, ID or password. All these things can be compromised if the security of an API is not done properly. There are basically three different types of APIs: public, partner, and private. As the name itself suggests, public APIs are available to everyone and are easiest to find. The partner APIs are limited to specific partners of the organization, and these are available to those specific groups. Whereas private APIs are hardest to find and they are meant to be used by developers within an organization. So, where to look for those APIs? You can look for APIs via your manual exploration. You can look it in GitHub, or you can read the documentation of an API. Then you can use different web application scanners to detect the API's endpoint. Scanners such as Nuclei would work fine. There are different fuzzing tools which are used to brute force the endpoint of an API using a word list. So in that way you can also discover APIs. Then there is reverse engineering an API where you use a tool called man in the middle to proxy swagger, which creates the API based on your crawling, like you are actually exploring all the functionalities of a web application, and meanwhile this tool will create a API request format. Now let us understand the latest OWASP API security risks for 2023. So OWASP is basically a non-profit organization which provides tools and techniques to the developers and security professionals so that they can create a web application free from any kind of vulnerability. So one important thing is, your API secure enough to keep the bad guys out but open enough to let the good guys in? So this is something which the developer should keep in mind while implementing the security, that since you have to block the bad actors accessing the data from your API, on the same hand you will have to manage the legitimate users availability of the data. So the first vulnerability is called broken object level authorization, which is a very common issue. It involves the manipulation of IDs to impersonate unauthorized data of other users. Say for example, I'm a user A and I am accessing my profile and I have been allotted an ID 12. If I am changing that ID from 12 to some other number, say for example 13, if I am able to read the data of user whose ID is 13, then that vulnerability is called broken object level authorization. The impact of this vulnerability can lead to data loss, data disclosure, data manipulation. In fact, unauthorized access to objects can lead to account takeover as well. There is an example attack scenario like I explained. Suppose there is a post editor. You have written a post and now you want to edit it. So there you get a endpoint like this API slash version 1 slash post slash 1 slash edit. Say for example the one is user ID for user A. Now if the attacker is changing this user ID from 1 to 2 and he is able to edit someone else's post, then there is this sorry then there is this broken object level authorization. Also there is a note for developers while implementing the any API they can follow these points. So implement a proper authorization mechanism that relies on user policies and hierarchy. Also use authorization mechanism to check if the logged in user has access to perform the requested action. And in case of what usually developers do, they allot ID like continuous numericals. Say for example 1, 2, 3, 4. Don't do that. In fact, replace those IDs with random and unpredictable values. The second API vulnerability is broken authentication. The name itself suggests this is introduced into an API due to weak or poor authentication mechanism, which is due to the missing security controls or misimplementation of those controls. Now, the impact of this vulnerability can be very serious. An attacker can gain control of other users' accounts. The data can be stolen, and in fact, unauthorized transactions can be taken place. The example attack scenario for this authentication vulnerability is it will permit weak password like if a user has used a very weak password and the web application is allowing the user to set a weak password, that can be compromised very easily. If credential brute forcing is also applicable since a developer has not added any rate limiting into the API, the brute forcing can be easily available and then as a result the credentials can be harvested. Now again a note to developers, while developing an API they should define strong authentication policies and standards, uh, unlike permitting weak passwords. Wherever possible implement multi-factor authentication. So in case first authentication layer is breached, we will have one more authentication layer. Also implement account lockout or capture mechanism to prevent any kind of brute force attacks. Also, this is common mistake usually developers do. They should not use API keys as a way of authenticating users. The third vulnerability is broken object property level authorization. Attackers can exploit endpoints by reading or changing the values of properties of object properties they are not supposed to access. Say for example, you have a Netflix account and you are not a premium user. You will not be able to use the services provided by Netflix. But what if you capture the API request and you yourself manipulate the account type and change it to the premium? If the Netflix has this vulnerability, then you will be able to enjoy all those premium stuff but just by changing the property by yourself. So this is what broken object property level authorization means. The impact of this vulnerability is again very serious. It can result into unauthorized access of data and data disclosure as well. The data loss is also possible and we can manipulate the data as well. So what do developers need to keep in mind to avoid this vulnerability? When an endpoint is exposed, make sure that the user have access to those properties of objects which are decided by developers. Also, allowing the changes in properties of objects that should be updated by client. If a client is updating any property of object, for example, we were updating account type here, it should not be change in the it should not result in change of code, right? So also return only minimum amount of data required according to the usage. Don't return unnecessary data. Also avoid using function that binds a client's input to code variables or object properties automatically. Moving on to the next vulnerability, that is unrestricted resource consumption. This vulnerability is due to inadequate traffic controls. For example, if multiple concurrent requests can be performed from a single local computer or using cloud computer resources to the API server, it can lead to unavailability of data to the legitimate users. Impact of this vulnerability can even lead to denial of service attacks, data harvesting, and since more requests are made for the resources, it can impact on service providers billing as well. Consider this attack scenario. An attacker uploads large image by issuing a post request to API version 1 image, which is the endpoint of the API. But after the upload is complete, API creates multiple thumbnail with different sizes, which make API unresponsive. If you are uploading an image of say 1 GB, since this is a payload, not a legitimate image, the API in the backend will create multiple thumbnails with different sizes. So in that rendering process, it can definitely attack. It is definitely an attack on the server, which can lead to denial of service again. So a note to developers: use container-based solution that make it easy to limit the CPU, memory, and number of restart and all. Also define a maximum size on all incoming parameters and payloads. Configure spending limits for all service providers, and most importantly, rate limiting should be fine-tuned based on your requirements. The next vulnerability is broken function level authorization, which is basically when an attacker abuses API functionality to perform CRUD operations. CRUD operations mean create, read, update, and delete operations on the database. It often involves replacing passive methods such as get with the active ones such as post, put, or delete. The impact of this vulnerability can lead to escalate the privileges. Any non-admin user can perform actions that are uh, only the privilege to admin. Administrative functions are key targets for this attack, which can be exploited to modify the account details. Consider this attack scenario. You can replace get with put, or you can modify the parameters. For example, you can add or modify role equal to admin, or there can be binary values such as admin equal to true or false. You can change to that to true. You can delete the invoice. You can add a new user as admin. You can in fact set account balance to whatever you want. A note to developers: the enforcement mechanism should deny all access by default. Also, you should review the API endpoints against these function level flaws. Identify functions exposing high sensitivity capability and develop controls to limit access. Make sure that all the administrative controllers inherit from an administrative abstract controller that implements the authorization checks based on a specific user's group or role. Next vulnerability is server-side request forgery, which is same into the web applications. So server-side request forgery occurs whenever an API is fetching a remote resource without validating the user supplied URL. In most of the cases, for example, you must have seen a web application allows you to import an image by a third-party application. In that case, if the server is not validating that third-party access, the attacker can add their uh, the attacker can add their malicious URLs and then request for resources from their own URL. So it allows sending crafted requests to unexpected destinations. The impact of this vulnerability can create a channel for malicious request, data access, or other fraudulent activities. It has the potential for data leaks and can lead to DOS. So consider this attack scenario again. Suppose a web page gets images from another website, say Unsplash. The attacker changes the URL for Unsplash to its own malicious URL, that can be something, and prompts the web app to download malware or a reverse shell, you can say. to get downloaded from that malicious site. In that case, the application can be compromised. So here again, the prevention methods can be the developers can disable the HTTP redirections, and most importantly, which can solve most problems of the vulnerabilities, is to validate and sanitize all client supplied input data. This is most important step. Also, developers can isolate the resource fetching mechanisms in your network, and you can use allow list for URL schemes and ports, accepted media types and all. Seventh vulnerability is security misconfiguration, which is appropriate security hardening is missing in this case across any part of API stack. Also, this can be introduced due to the missing of latest security updates. Uh, Course misconfigured is also an example of security misconfiguration. Course, which is basically cross origin resource sharing, and this can also be introduced if TLS is missing. So impact of this security misconfiguration can lead to exposure of sensitive user data or in fact full server compromise. Consider this example attack scenario. Suppose a social media page offers you a direct message feature allowing the private conversations. So you can even send direct messages or you can keep private conversations. So to retrieve the new message, this web application uses logic of this API request get slash dm slash user update and then customer ID equal to whatever 12345. Since API response does not include cache control HTTP response header, the private conversation will get end up by caching up by your web browser. So what attacker can do is attacker can read all those private conversations from browser cache file. So this is an example of security misconfiguration. A note to developers: implement hardening procedures while developing the API. Define and enforce all API response payload schemes, including error messages, to prevent sending information back to attackers. Do not send empty or do not send any irrelevant information back. Always prepare a proper model for whatever response you are sending back to the client. Ensure all API communications are encrypted over TLS. Next vulnerability is lack of protection from automated threats. So this is basically abuse of legitimate business workflow through excessive automated uses. Rate limiting also gets less effective in this case. Uh, the attacker can easily get sensitive functionality in an automated manner. The impact of this vulnerability can be it can prevent legit users from accessing the services. The data becomes unavailable to the legitimate users. It also allows attackers to send excessive amounts of messages and comments, and easily it could lead to a spreading of fake news. So an attacker can write a script that will keep on continuously posting and spamming the comments of a post on YouTube or on Instagram if this vulnerability exists. This can also lead to loss of critical business activity. Consider this attack scenario. Suppose a ride-sharing app provides referral program where user can send invite link to their friends, and once their friend is joining, they can earn some points or rewards. So now what attacker can do? Attacker can write a script to automate this registration process with credits getting added to his wallet. In that way, uh, whenever so what this script is doing, the script is continuously adding registrations, and the attacker has added his own referral ID in each registration. In that way, he can earn unlimited point. This is due to the lack of protection from automated threats. Now, to prevent this vulnerability, developers can consider IP blocking of Tor exit nodes and well-known proxies. Also, developers can deny services to unexpected client devices, for example, headless browsers. Also, identify the business flow that might harm the business if they are excessively used, and continuously keep on monitoring them. The ninth vulnerability is improper inventory management. Improper inventory management is when an attacker gets unauthorized access through old API version endpoints. What basically happens is developers do not retire the old versions of the API and keeps on introducing the new one, since old one has vulnerability. But attackers can easily look for these retired endpoints and can exploit them. The impact of this vulnerability can lead to sensitive data or takeover of the server from an old or unpatched API version connected to the same database. Exposures can be possible via the third-party access as well. So, uh, consider this example. Suppose a social network implemented rate limiting to prevent credential brute force in his page. But attackers found that there exists one more web page with a subdomain called beta.socialmedia.com page where all the functionalities are same but rate limiting is not introduced. So an attacker can easily brute force the credentials to look for the legit ones and then can log in as the user. So a note to developers, deploy and manage all the APIs in Gateway and don't forget to define rules for versioning and retirement. Periodically, they should also audit the third-party access of APIs. Now the last one is unsafe consumption of APIs, where the developers tend to trust data from the third-party APIs more than the user input. Thus, they adopt weaker security standards in input validation and sanitization that leads to unsafe consumption of APIs. The impact of this vulnerability can lead to exposure of sensitive data, data theft, or account takeover as well. Now consider this attack scenario. Suppose an attacker inserts malicious address data to validation site used by client. What if client fails to validate data and gets exploited? An attacker can prepare a GitHub repo named this, which is basically an SQL injection command, not an SQL injection, it's just a SQL query to drop the database, which is basically deleting the database. Now, after integration from attacked app is done on the malicious repo, it will build and SQL query to delete the database will run. A note to developers, when evaluating service providers, assess their security posture. Also ensure that all the API interactions happening over a secure communication channel. Don't blindly follow the redirects. It is better always to use an allow list. Also, most importantly, once again, always validate and sanitize user input data. Now, moving on to our next topic, that is API penetration testing. Let's discuss an overview of tools and techniques required for API pen testing. So, starting with the reconnaissance. In the reconnaissance stage, we try to hunt for information related to our target so that we can use it to further exploit the vulnerabilities. There are two methods of reconnaissance. First is passive, second one is active. In the passive reconnaissance, we do not directly engage with the server. We, in fact, try to look for the publicly available information. This information can be available on GitHub or Google or in the directories. So in case of API reconnaissance, we can try to learn more about the APIs in the documentation shared by developers. We can also look for the subdomains or APIs endpoints using Google Docking and Git Docking. So as you can see here, using this doc, we can search for APIs of our target. Here we can replace target with our own target. For example, we can look for APIs of tesla.com. Same goes with the git docking, where we can use this dork of extension type, where we are filtering our search results to the JSON objects, to the JSON files. Also, we can look for Wayback Machine, which is actually an internet archive. So, suppose a developer has deleted an API, but the Wayback Machine has captured it. So, you can go back to that time when the API was live and try to hunt for information, try to fetch information from database using that APIs. Also, there are many different ways available. So, for example, you can use Shodan, which also will give you API. Now, the next one is active reconnaissance. In this part, we directly engage with the API. In this case, we usually make use of fuzzers to discover the endpoints. So, a fuzzer is basically a tool that will brute force names of APIs from a word list by sending requests to the server. If the API if the API endpoint exists, we will get a response of HTTP status 200. Otherwise, some other status will be there. There are two example one-liner scripts that can be used to hunt for API. Suppose you have this target domain.target.com. You can write an nmap script. Also, you can make use of MS to hunt for all the subdomains and then grep the results containing API, because we know sometimes API are in the format of api.subdomain.domain.com. So in that case, you can hunt it from there. Now let's see what if there is a broken object level authorization. How can you test it? So this is very easy. What you have to do is you have to create two accounts. Say we will be address these accounts using user A and user B. So now since you have logged in as user A, you can create some resources on the side. For example, you can try writing some post or comment. And now if you are able to access those resources as user B. This means the web application has broken object level authorization error. Also, you can try changing the endpoints or IDs to access other users resources, and if you are able to access it, this means there are object level authorization error. For example, you can see in this image, when this is a legitimate user request where a user is requesting all the financial information for a user with ID1. But what if the ID1 is replaced with ID2, which is actually the user ID of user 2? If the server is returning back the financial information of user 2, this means this is case of broken object level authorization. These are some tips or some things you can try to check for this vulnerability. Object IDs in URLs tends to be less vulnerable, so you should now try to put more efforts on the IDs that are in HTTP headers or bodies. You can also use session label swapping, which is basically swapping the tokens or session IDs of users and see if you can access the resource of other users. Also try numeric IDs. If an endpoint receives a non-numeric object ID, for example, if there comes a parameter with email, that is a non-numeric basically, but try to replace it with a number and see what happens. Some authorization mechanisms work partially. So in that case, you might end up getting 401 or 403 error code. So in that case, you can keep trying with different IDs. Most probably you can get access to the resources. Also, there are some techniques of bypassing this. For example, instead of ID as numericals, try to enclose it in square bracket and make it as array object and try to send the request and see what happens. You can also make it like a JSON object and forward the request authorization. You can basically change the IDs, or you can basically add another parameter which was not there. Now the next vulnerability is broken authentication. Let's see how we can exploit it. So I hope you all are aware how to use burp suite. So in the burp suite, you will have to intercept the traffic and send that request to the intruder. So here I have sent the login request from a intentionally vulnerable API. That is creepy. So as you can see here, this endpoint is basically checking for login, and here are the parameters. We have email and password. So select these two parameters and add this for testing. Now, after you have added all these, let's set payload. So in the payload one, add all the payloads that can be easily found on GitHub. So in the same way, add password and you can then start the attack. So you can see this payload one is for email and payload two is for password, and it will keep on trying every time it will keep on trying the login process, and you will have to observe this status code. If you are getting a 200 status code, which means the request was successful and you have successfully logged in. Now let's see how you can test for broken function level authorization. Basically understand how the create, read, update and delete operations on resources of user A is working. Then swap out user A token for user B's, which is basically using user B's token in case of user A, and then using get, put, post or delete methods, send the request from user A to request user B's resources. Check if user A's resources to validate changes have been made using user B's token or not. If done, which means you have discovered the broken function level authorization vulnerability. Now let's discuss about first case study, that is of Instagram. the issue was account takeover. Account password reset requires 6-digit code, right? So the researcher found the API that was responsible to submit the reset code guesses. That API was limited to 200 requests per IP, but researcher demonstrated could rotate through 5,000 APIs in seconds. So in that way, he was able to bypass this rate limiting, and which enabled account takeover. Since you can guess the 6-digit code very easily by using the brute forcing method, you can also guess the password reset code. Next case study is of Coinbase, where the issue was that the user can sell crypto coins that they even don't own. User scraped API calls from web user interface and then identified all four parameters that were required for any Coinbase transaction. Attacker then manipulated these parameters via API class, and he was able to sold the crypto coins that he did not even own. So the reason was missing logic validation check in a retail brokerage API endpoint. Do you know, in 2020 there was a loss of $2.2 trillion because of this API security only. So let me summarize all the studies we did in this presentation by explaining one more point, which is the three pillars of API security, that are governance, testing, and monitoring. Governance, which means developing secure APIs. Developers should keep security in mind from the first phase of software development lifecycle. They should not keep it for later. Also, testing the functionalities of API should be done on a regular basis. After the APIs are sent to production, the monitoring should be done. Determining any threat in API is very important. So these are some resources which you can access to learn more about the API security. There is this awesome API security GitHub repository. Then there is this list of endpoints which you can use to fudge. You can find this PPT on my GitHub so that you can access all these resources. Thanks for bearing with me, and this was all about API security. If you have any queries, you can find me on Twitter, GitHub, LinkedIn, and you can in fact send me mail. I would love to answer your query.